Hi, I'm Teacher Thomas. Welcome to A-Level Mathematics. This is the specimen paper for 9231 Further Probability and Statistics for the 2020 exam series, question 3. Employees at a particular company have been working 7 hours each day from 9 a.m. to 4 p.m. To try to reduce absence, the company decides to introduce flexi-time and allow employees to work their 7 hours each day at any time between 7 a.m. and 9 p.m. For a random sample of 10 employees, the numbers of hours of absence in the year before and the year after the introduction of flexi-time are given in the following table. Test at the 10% significance level whether the population mean number of hours of absence has decreased following the introduction of flexi-time, stating any assumption that you make. In this scenario, we're looking at differences. We're going to use a paired sample t-test. Let's begin with the last part of the requirement, the assumptions. There is one assumption that we need to make or state. The population of differences is normally distributed. The test statistic that we'll be working with is the mean difference minus k, which I'll discuss, over the standard deviation of the differences divided by the square root of the sample size. The k in the numerator relates to, in this case it will be 0, it relates to whether we're evaluating there's no change or the change is no more than some number or no less than some number, etc. In this case, the requirement is to evaluate whether there has been a decrease, not a particular size of decrease, so our k is going to be 0. We want to state the null and alternative hypotheses. The null is that the mean has not decreased, and the alternative is that the mean has decreased. Now I'll evaluate the individual metrics that I need for my test statistic, the average d bar. Let's go up to the top. Notice in the table we have rows before and after. Below, I'm going to calculate the d, and I will use after as a positive value and before as a negative value. Going across, I end up with negative 8. The after minus the before is the calculation I'm doing for each column. Negative 3, positive 4, negative 2, 11, negative 3, negative 17, negative 10, negative 6, and 0. The average of those, that's my d bar, is negative 17 over 5. The k, as I've mentioned, is 0. N is 10. And for the standard deviation, we're going to need to know the sum of d, the sum of the differences. That value is negative 34. And we'll also need to know sum of d squared. So if you take each of the differences that I've calculated and square them and add those squares, you get 648. As a preliminary calculation, I'll find the standard deviation of the differences, and that is the square root of 1 over n minus 1. In our case, we have a sample size of 10, so 1 over 10 minus 1, times the sum of the squared differences, that's 648, minus the sum of the differences, which is negative 34, that amount squared, over the sample size of 10, and this rounded is 7.691. I don't want to use a rounded value as an input, so you can either store this value in your calculator, or when you do the calculation of the test statistic, instead of calculating this preliminary standard deviation, you can simply make one big calculation so that the output in your calculator is precise. And now to calculate the test statistic, our mean, negative 17 over 5 minus 0 over the ratio of the standard deviation, which is 7.691, and I'm going to indicate that there's a more precise value there, over the square root of the sample size, which is 10, which simplifies to negative 1.398. I want to compare this test statistic to the critical value, and the critical value is going to come from the t-table using degrees of freedom of sample size minus 1 and a significance level as given 10% up in the requirement. And notice that we are evaluating for a decrease, not a change, but a particular direction of a change. So this particular direction means we're working with a one-tail test, and that will translate into working with 0.9 as a lookup value. Here I find the value from the t-table of 9 and 0.9, 1.383. I'll take the absolute value of the test statistic. We calculated negative 1.398. And the reason I'm taking the absolute value is because we're comparing to a positive critical value. Comparing this to my critical value of 1.383, I notice that the test statistic absolute value is greater than the critical value. Thus, I will reject the null hypothesis and state the meaning of rejecting the null hypothesis, which is that mean hours has decreased. And this completes the requirements for question 3.